Welcome to the intermediate value theorem. This theorem basically states that for an interval of x values, such as seen here, there must, and for the function to be continuous within these x values, there must be a y value associated, since the function is continuous, every single x value within that interval has to have a y value. So let's walk through a question. For the interval of 6, 9, therefore meaning the x values of 6 and 9, find f of c when c is equal to 7. So this graph is f of x. Now when f of x is replaced with c, and with c being 7, it'll be f of 7. Now 7 falls inside the interval of 6, 9. We can see that through the continuous function represented here. So we can see that 7 approximately equals 2. And we can see on our table that it equals around 2.01. So the intermediate value theorem proved to work. Cases where the intermediate value theorem doesn't work is when the interval has any discontinuous points or jumps or gaps or whatever. So with this we can see that there are no discontinuities within the interval, allowing for us to see that the intermediate value theorem does apply. Now, along with this, we can see the reason that the intermediate value theorem has to be only applied within an interval is because if it wasn't, then every function to be represented by the intermediate value theorem would have to be an infinite function and infinitely continuous, which in the world of math is not, I would say, not the most common thing, at least in calculus questions. So that's why the intermediate value theorem only applies to those within the interval. As if it is continuous within the interval, then the x values within the interval will have to be represented, as the graph has to hit every single x value before it can reach the next, since it is continuous. So yes, that is my explanation of the intermediate value theorem. Thank you for watching.